Hey guys, my name is Neel and welcome to Neel Workshop Zone. So in the previous episodes we talked about basic proportionality theorem, Thales theorem, how to prove them, etc. So if you haven't checked it out, then I recommend checking out those episodes. So in this episode we're going to be talking or solving some fill in the blanks and sums. So without further ado, let's talk about it. So I got some questions and sums right here. So the first question is, all circles are dash, congruent or similar. Now you have watched my previous episodes, which gets important as we're moving on with the topic. I think you know the answer to this, but if you're still a little confused, congruence is where both of the figures have the same shape and the same size. So for example, it's not exactly this, but I'm trying to do my best. And there are little differences, but let's just imagine that both of these have the same diameter and the same radius. In that case, both of these are congruent because they have the same shape and same size. So for example, let's say this is 1 centimeter and let's say this is 1 centimeter as well. So they are congruent because they have the same shape and size. So that is congruent. On the other hand, similar or similarity is where both of them can be same shapes, but they're obviously not, they don't have the same size. So for example, this can have 2 centimeters, this can have 0.5, etc. So there is a difference between congruency and similarity, and so this kind of answers the question that all circles are similar. Same with the next question, which is, all squares are similar or congruent, and the answer is pretty obvious, it is obviously similar. So now let's solve the third blank or third sum. So the third one is, all dash triangles are similar, isosceles or equilateral. Now the answer here is equilateral because all equilateral triangles have the same side. So for example, if you say this is 3, 3, 3 and this over here is 6, 6, 6, then obviously there is some, they are similar in some ratio. So obviously the answer for the third one is equilateral. So the next one is, two polygons of the same number of sides are similar if A, the corresponding angles are dash and the corresponding angles are dash. So they get two options here, equal and proportional. So we need to write down in those two blanks. So basically, two polygons of the same number of sides are similar if the corresponding angles are dash and the corresponding sides are dash. So basically, they're asking, if the angles needs to be equal or if the angle needs to be proportional and what about the sides. Now, if you have watched that video, haven't discussed about this, but basically for two figures to be similar, their corresponding angles needs to be equal and the corresponding sides needs to be equal in some ratio or equally. So obviously the answer for A is if the corresponding angles are equal and their corresponding sides are proportional. So now that we have done next question, now let's go to the other question, which is, give two different examples of pair of similar figures and non-similar figures. So this is pretty simple. We could give basic. Okay, I still don't understand why this is happening. I will try to solve it as soon as possible, but apparently it stopped again. I don't understand why. But let's continue. So we're basically talking about the next question, I'm pretty sure, which it's probably not recorded. So let me go through it again. Give different examples of pair of similar figures and non-similar figures. So it's pretty obvious again, similar figures are figures which are similar. So for example, two triangles or two circles, etc. Non-similar figures are ones which are not similar. So for example, a square and a circle, etc. So that is two different examples of pair of similar figures and non-similar figures. So next one might be a little tricky. So state whether the following quadrilaterals are similar or not. And they gave this diagram. They wrote 1.5, 1.5, they are centimeters, 1.5 centimeters, 1.5 centimeters, and 1.5 centimeters. On the other hand, we have a square which has 3 centimeters, 3 centimeters, 3 centimeters, and 3 centimeters. I'm sorry about my handwriting, but basically they are asking if both of these quadrilaterals are similar or not. Now, at first glance, when you look at it, the answer might seem obvious, which is yeah, they are similar because both of their sides are proportional and their angles are equal. But you would be mistaken because it's a little tricky. Because here they didn't give the angles, so we don't really know if this is similar to, a square. But by paying close attention, we can kind of understand it. So, for example, here you can see that the angles are 90 degrees, or you can see the angles clearly. On the other hand, the angles over here are quite tilted. So, for example, they're kind of like this, while square is a lot more different. So, I think you can understand what is the thing. So, for two figures to be similar, again I said the corresponding angles needs to be equal and the corresponding sides needs to be in the same ratio or proportion. And the sides are in the same ratio or proportion, but the angles are not. So, that is why both of these figures are not similar. So, yeah, those are some of the sums and some of the fill in the blanks. This is a short video, but it is really important, especially for something like this. So, hope you enjoyed this video. In the next video, we'll probably talk about the Pythagoras theorem and how to prove or how to show that it works. And also we'll talk about what is Pythagoras theorem and how it is used. But again, we'll talk about it in the next episode. But for now, hope you enjoyed this video. If you did, don't forget to like, share, subscribe, hit the notification bell so you don't miss out any new videos. And that's all folks, and see you in the next one. Bye bye.